driving became a major mode of transportation. We've come a long way since then, and the technology involved in driving, from the fuel to the cars and even the roads we drive on, continues to advance. We've talked about a lot of these advancements here on SciShow, so today we're going to take a look at what the future of driving may look like. It took less than 2 decades to go from the first Model T to the 15 millionth one, and nowadays there are more than 1 billion cars driving around. While that is amazing in some ways, it's been pretty crummy for the planet because the vast majority of those cars run on fossil fuels. But many researchers are trying to change that, so in the near future, what you fill your tank with could be very different. Like, you might be filling it with your table scraps. I'll let younger me fill you in on that. It's 3 in the afternoon on a Wednesday when you hit the afternoon slump. You're tired. And probably not just because you were up late binge-watching season 4 of Buffy the Vampire Slayer. Your body is low on energy, so you grab an apple for a quick snack. Food is energy, after all, that's why we eat it. But instead of throwing away that core when you're done, try putting it in the garbage disposal. There's a lot of energy left in there, and this way, it might be converted into something useful. Because when food waste ends up in landfills, it actually creates a lot of problems. It takes time for that uneaten apple core to decompose, and meanwhile, bacteria are turning it into methane. That's an issue because methane is a greenhouse gas, and it's actually significantly better at trapping heat than carbon dioxide, which got a lot of scientists thinking, what if you could figure out a way to control how the food waste decomposes, and in the process, produce energy we can actually use? That had the potential to help the planet and make lots of money, so win-win really, but it wasn't gonna be simple. The first challenge was just getting the food waste itself. Recycling programs are pretty successful, but it's still hard to get people to agree to scrape the food out of the takeout container before they throw it in the trash, or get restaurants to separate food scraps. Cities are slowly starting to get on board mandating that commercial establishments like restaurants send no more than a certain percentage of their waste to landfills, but even after they've separated out the food waste, there's still the matter of getting it somewhere to be processed, not to mention figuring out how to process it. At first, cities decided to take advantage of existing sewage treatment systems. We've talked here on SciShow about where the stuff in your toilet and sink goes after you flush, and eventually, part of it ends up in an anaerobic digester. Basically just a giant tank full of sludge and some specially selected microorganisms, but very little oxygen. Bacteria would normally digest that sludge using a reaction that has carbon dioxide as one of the products, but making carbon dioxide requires oxygen, and when there isn't enough around, they have to do the best they can with what they have. So they end up producing methane instead, and that's much more useful to us because the treatment plant can harness that methane and turn it into a usable fuel. When your apple core goes down the drain, it lands in the sewage system and eventually ends up in the sludge, where bacteria can use it to produce even more methane. So at first, cities simply added their food waste to the mix. Once they'd figured out that this was an effective way to turn food waste into methane, companies started building treatment plants specifically designed to handle food waste. Many of these plants have deals with local utility companies that are able to sell the extra fuel in the form of heat or electricity, or just compressed natural gas. Sell enough, and they turn a profit. But methane still isn't an ideal fuel. To move it around or burn it, you have to compress it first, which takes extra energy and makes the fuel less efficient. And while methane is easy to use in power plants once they get it, it's more difficult to use compressed natural gas to, say, power a car. That's why these days many companies are looking to turn food waste into an even more useful form of energy: ethanol, the stuff that is in your tequila, ethyl alcohol. There are plenty of industrial plants that produce ethanol from things like corn, and they've been doing it for decades. One of the more common techniques uses enzymes to convert cellulose into sugar, and then allows yeast to turn that sugar into ethanol and carbon dioxide. Since those plants use very specific raw materials, or feedstock, the chemical reactions are easier to control. Producing ethanol from an unpredictable mixture like food waste is more complicated. But there are already biorefineries that use other kinds of waste to produce ethanol, like one in Alberta that started operations last year. That plant takes what's known as municipal solid waste, anything that can't be recycled or composted. Then it sorts that waste, separating out stuff that can be used as feedstock for that plant, like non-recyclable plastics and soiled cardboard. The feedstock is processed using gasification, where high temperatures, hot sand, steam, and oxygen are used to convert it into a mixture of carbon monoxide and hydrogen called syngas. Using catalysts to help spur the reactions along, the syngas is turned into chemicals like methanol and ethanol. Companies haven't yet applied the technology to food waste on an industrial scale. They're working on it. This course is about machine learning, modeling, and simulation in the world of